Hi guys, today we are going to talk about the homework 3. So homework 3 has three big questions. So if you can understand the first one, actually it would be very easy for you guys to solve the following two. Okay, let's get started. Firstly, let's read question 1. If the production function is given by, remember that this is not the small yt, it's capital YT. Okay, capital YT equals AKTLT power of 0.5, where Y is the output, A is the technology. Actually, it is be a constant number value. Okay, and L refers to the labor stock and K is the capital stock. Suppose the saving rate equals 0.6 and the depreciation rate delta is 0.3. So now we are going to solve the following questions. Actually, if you look at this kind of question, always the first step is to convert the capital Y, capital T, capital L to the capital per capita, or you can say per worker. So it's just to divide LT for both hand side. Okay, let's do it together. So now you have YT equals AKTLT's power of 0.5, right? So let's rewrite it like A times YKT 0.5 LT 0.5, and you decided to have the capital per output per worker, capital per worker, right? So you just divide LT for both hand side. So now divide by LT. So for this part, if you can remember the first discussion, you will know that this is just the output per worker, right? And then how to convert this part to the capital per worker is just using, it's like KT 0.5 divided by LT, right? I just rewrite LT to LT 0.5, LT 0.5. And then you can get this one is copy it here because it is constant. KT 0.5, small kt, and this one is just 1, right? So we just ignore it. Now we have a new equation where it is yt equals k a times kt power of 0.5. And that's it. This would be always your first step to solve this kind of question. Okay, now let's look question A. Write the output and capital accumulation equation in terms of capital per worker. So you need to write two equations. First one, output accumulation equation and capital accumulation equation. So for the output one, how to accumulate output, it is using the investment and consumption, right? If you can got the output, then there would be two ways for you uh, to deal with this output. The first one is invest to next period, and the second one would be consumption. Because remember our example of running a restaurant. If you can earn some money today, you need to buy some raw material like the beef, the vegetables, and some flavor for tomorrow's operation, right? So this would be your investment. And the second part, because consumption means that if you earn money, of course you want to let you happy, right? If you want to consume, so it would be two parts for your output, investment to the next period, and CT, consumption. And remember our assumption that the saving rate is fixed. So you invest to the next period, it means that you save this money to next period. So you just use S times YT. YT is just AKT, the power of 0.5, right? And consumption. Now, so this one would be the output accumulation equation. Okay, then next one, what would be the capital accumulation equation? Capital, tomorrow's capital actually comes from two ways. Remember your investment from next period. This is the money that you save from the last period. And the second one is that your last period capital is not used up. There would be some remaining capital. It means that except the depressed capital would be some remaining 1 times sigma. This kind of proportion capital can be used for tomorrow's output. Okay, so according to our this one, let's write it because S is 0.6, AKT power 0.5, and CT. And now S copy here. Delta is 0.3, right? So 1 minus delta, 0.7 KT. And that's it. So this is the capital accumulation equation. So this is for question A. And for question B, find the steady state capital, output, and investment and consumption. Remember, what is the steady state? Steady state means that KT plus 1 equals KT equals to K, right? It means that for every period, the capital per worker would be the same. So actually, we can solve it from the capital accumulation equation because for this equation, you have KT plus 1 and KT, right? And you just like KT plus 1 equals KT equals to K, then you will find the solution. Okay, so let's look at now still you have 1, 2, 3, 4 equations to solve. For the capital one, because now this is the steady state and you are going to use equation 2. According to equation 2, just replace KT plus 1 KT to K. It's just like K equals IT is 0.6, A, K 0.5, power of 0.5. And this one, right? According to question 3. And you will get, okay, just rewrite it because we want to have it times AK 0.5 and 1 minus delta K. Then if you like this equation holds, then you will get K 0.5 equals SA divided by delta. Okay, now you can get, because here do you know S is 0.6, right? The A is constant value and we don't know it. And delta is 0.3. So now you get K power of 0.5 is 2A. So you can get K equals 2A squared is just 4A squared. And then if you can get what is the capital in steady state, then what would be the output? you're going to use the first production function because now you know yt here equals a times kt power 0.5, right? You just replace it, y equals a times k 0.5 equals a times, just substitute the k's value here. Then you will get the output. Okay. And then what would be the investment? Investment is just I just equals S times Y, right? And you know S is 0.6. So 0.6 times 2a squared is just 1.2a squared. And what would be the consumption? Remember, output equals investment and consumption. You just use C equals Y subtract I. You're just using 2a squared subtract 1.2 a squared. You will get 0.8 a squared. So this is the steady state of consumption. And for question C, what would happen to the steady state capital if the saving rate equals 0.8 and depreciation rate equals 0.4? So if we can go back to our question B, once we can get K's value, then in the following we will get output, investment, and consumption. So the key point is that if K change or not, okay? Because according to this equation, we get K 0.5 equals SA divided by delta. And now S is 0.8. It doesn't change constant value. Delta equals 0.4. Still, now you can see still K power of 0.5 equals 2A. So still K for A squared doesn't change. So if K doesn't change, then output doesn't change, then investment doesn't change. So there would be no change for the steady state for the capital output and the investment and consumption. Always no change. Okay. Now we can look at the second question. If the production function is given, now you have the production function here, and where YT is the output per worker, KT is the capital per worker, and the saving rate and the depreciation rate is here. It means that S equals delta plus 0.4. Okay, and remember now we still need to get what the steady state of capital output investment consumption. Okay, according to this equation, equation 3, okay, because now this is power of 1 over 3. So no, maybe not. In the steady state, delta K equals SK 1 over power of 1 over 3. So according to this equation, you can get K equals delta and S equals delta and 0.4 times K equals S. Okay, not my fault. Delta K equals delta and 0.4 K power of 1 over 3. And then you can get K equals delta and 0.4 divided by delta. So now this is the K's value. Remember, all the steps are the same. Now you have what is the capital then can you get what will be the output? Because you just get the value of k, right? And you know what's the production function. So y is just k's 1 over 3, power of 1 over 3. So y's value is delta and 0.4 divided by delta, power of 1 over 2. Okay, and then the steady state of investment. Investment is just I equals S times Y. And S is delta and 0.4. Y is delta and 0.4 power. Okay. And you can get, if you just leave it here, it's okay. And what would be the consumption? C, just Y subtract I. And you will get 0.6 subtract delta times delta and 0.4 power of 1 over 2. Okay, now you can get the steady state of all the requirements. Okay. For the last one, if the production function is given here, and I will not copy it because you can get the production function can be written as here. And then the saving rate equals S equals delta. And find the numerical values of the steadiest capital and output. Always use this one. Now you have delta times k equals sk power of 2 over 3, and delta and s are the same, so delete it. Then you will get the k's value would be 0 or 1. Actually, k cannot be 0, so k's value is 1. Okay, now if this is a steady state of capital, then I think you will know what's the steady state of output. It would be y equals k power of 1 over 3 is just 1. So this is the answer for question for the last question. If you can follow these steps, you will always get the correct answer. Okay, so that's it for today. Okay, if you have any questions, you can ask me. Okay, bye.